Alright class, today we're going to continue the study of kinematics while talking about 1D motion in the y direction. So let's revisit what kinematics means. Kinematics is the study of motion in terms of displacement, velocity, and acceleration. We previously worked only in the x direction, so now we are going to be working in the y direction. And then we're going to put them together and work them both. Hang on just a second, I'm trying to figure out my camera. There we go. I'm trying to make it a little brighter, but not red looking. And I don't want the red dots. Okay. Whenever we talk about y direction, kinematics in the y direction, basically we are talking about free fall. And free fall is falling while experiencing only acceleration due to gravity. So we are going to ignore air resistance while working with free fall. You have probably covered before in some of your other classes, maybe even in middle school, that the gravitational acceleration near Earth's surface is 9.8 meters per second squared, but we will use 10 because 9.8 rounds up to a nice round 10, and it's easy to use, it's easy to do calculations with. You can cancel zeros out. Everyone uses it on the AP test. And so we will use G equals 10 meters per second square. We will still be using the big 5. But they're going to look a little different. Instead of in the x direction, we will have the y direction. Instead of A, acceleration, we will be using G. So the big 5 now look like this. Change in y equals vt. Number 2 does not change at all. I'm wrong. The A changes to a G. Number 3, the x changes to the y's. Plus v naught t plus 1/2 gt squared. I always forget that a changes to a g. Number 4, y equals y naught plus vt minus 1/2 gt squared. And number 5, v squared equals v naught squared plus 2g y minus y naught. So the x has changed to y's, the a has changed to g's. I'm going to work a couple of example problems for you. So you can pause this if you need to get the rest of these notes. The first one I'm going to work for you is a rock is dropped from a cliff 80 meters above the ground. How long does it take to reach the ground? Well, we're going to write out our x naught, x, v naught, v, a, except for now it's going to be g, t. And I screwed up. I'm so used to writing the x's, I meant to write y's. Okay, so we circle what we're given. 80 meters, underline what we're looking for, time. So, we're going to assume that our y naught is going to be 0 up here and 80 meters down at the bottom since it is falling. So our y naught is going to be 0. Our y is 80 meters. We do not have our v naught or our v. Well, we have our v naught because it was dropped from rest, so we can assume that it's at rest. So there are things that we can assume in problems. Our g is going to be minus 10 meters per second squared because it is falling. So that's going to go in the negative direction. Positive is up, negative is down, and we're looking for time. So there's what we have. We don't have the final velocity. So we pull out our big 5 here, and we see what equation we can use. And we're looking for time, so it's going to have to be one of these 4, or one of these 3, sorry, because we do have acceleration, so it's either going to be equation 2, 3, or 4. We have y, y naught, and v naught. So it looks like it's going to be this one right here, because this is the one we have v naught with. So I'm going to write that down, y equals y naught plus v naught t plus 1/2 gt squared. Now the really cool thing about this is that because y naught is here, where we drop the rock, and y is down here, and y naught we're assuming is 0, this thing right here cancels out. Now v naught, it was dropped from rest, so our initial velocity is 0, and what's anything times 0? 0. So this term cancels out, so we only have y equals 1/2 gt squared left, and we are solving for g, or for t, sorry. They sound alike. So I need to move 1/2 by multiplication. 2's cancel out. I need to move the g by division. G's cancel out. And I'm left with t squared equals 2y over g. I need to square both sides. And then I have t equals the square root of 2y over g. And because y is falling down, this actually should be a negative 80. And then I can just plug in my numbers. 2 negative 80 over negative 10. Take the square root of that. And so what I have here, big round 10 goes into 80 8 times. The negatives cancel out. We're left with 8. 8 times 2 is 16. The square root of 16 is 4. 4 seconds. Our meters cancel out. Once we take the square root, the s squared goes away, and we're left with s. So that's the beauty of using 10 for gravity.